In 4.4, we're going to talk about trig functions of any angle. We're going to evaluate some angle theta by sine, cosine, tangent, and the other functions. And it's not just going to be any angle in the first quadrant, right? So that's what we mean of any angle. So as a review, this is the scenario we're looking at, right? We have our x and y coordinate plane, and we have a point along the circle, and when we open from the standard position here on the x-axis all the way out, it creates an angle theta, right? The angle is between the initial side and the terminal side. So that's what's considered as standard position, right? So something that is not in standard position would be if you had your xy coordinate system like this, and maybe you had something like this, and then here in the middle was theta. So that would be not considered in standard position as compared to what we have on the left side. Okay, so that's something to keep in mind. So whenever we talk about what is standard position, you know what it means. Okay. So that is my quick review, or my quick recap of some of the things that we really need to be aware of. So let's talk about what we mean by the definitions of trig functions of any angle. So theta, as we know, has to be in standard position, and theta is the angle. The point P is a point with coordinates x, y, and it is a point on the terminal side of theta, like we mentioned earlier. Then this may be a little bit newer, but we have r, or the radius, the length of the hypotenuse, if you will. So this definition here is very particular to this example that I'm giving you. So it is the distance from 0, 0 to the point x, y. So from here, from 0, 0 all the way out to x, y, which is that point right here. So this is just for you to know, and it's not really going to be applied in the next couple problems or the material that we're talking about now, but later on it will be, and we'll come back to this definition. So no need to memorize it right now, but at least know where it came from and what we're talking about. Okay. In this figure, we show all the different components that we need to be aware of, right? So here's my x and y axis. Here's my initial side, and then the terminal side is this blue line, and it just opened in standard position, right? Counterclockwise, creating an angle theta. So here's x, here's the y, and here's the r, right? Those are all the different lengths. So you may be already catching on to where we're going with this, since we're trying to define the different trig functions, right? So how do we define them in terms of this picture? So we have the picture here on the left, okay, which is the same as the previous slide, if you will, and we're going to use SOHCAHTOA, okay, which is that acronym to try to help us remember what is the definition for sine, what is the definition for cosine, what is the definition for tangent. Okay, so sine of theta, so theta being this angle here, is what we're going to use as a reference to help us figure out what is sine. So sine, if you remember, is the opposite over the hypotenuse. So sine is going to be the opposite, which is y, over the hypotenuse. So it's the length y over the length r. Cosine is adjacent over hypotenuse. So the adjacent side is the x, and the hypotenuse, or the radius of the circle, is r. And remember, I'm using this as my point of view, if you will. I am looking out and considering this the opposite. This is the hypotenuse, or the radius, and this is the adjacent side to the angle theta that I'm looking at. Tangent is opposite over adjacent, so y over x, given that x is not 0. And this is just a precaution, because in mathematics you cannot divide by 0, right? Otherwise it would be undefined, and that is okay as well. We know it's undefined. So we've done the most popular ones, which is sine, cosine, and tangent. What about the ones on the right side, which are the reciprocals? And those are just, like I said, the reciprocal of the function that is across from it. So cosecant is the reciprocal of sine. So all we have to do is flip the fraction, r over y, given that y is not 0. Secant, it is the reciprocal of cosine, which is r over x, again, given that x is not equal to 0. Cotangent is x over y, given that y is not equal to 0. And those are the 6 definitions. Again, I wouldn't try to go and memorize these values, since all you need to know is the different definitions for sine, cosine, and tangent. Go through them and make sure you understand them, and by the time you do many problems, you'd memorize them without really trying to memorize them. So that's the best advice, is to try to do some work with those functions versus just sitting there trying to memorize them. Okay? The next thing that I need to talk about is creating a right triangle given some point P. So you'd be given a point, and you want to then figure out the 6 trig functions. So in the first picture here, if I'm given the point x comma y, I need to draw the point, right? That's kind of what I'm saying. Then I need to connect a couple things. I need to go from the origin, which is here at 0, 0, all the way out to that point. That gives me one side of the triangle. Then what I'm going to do is draw a line connecting to the x-axis. So I create a right triangle, and then inside of it is my angle theta. This right here is the distance x, this right here is the distance y, and then right here is the distance r. Now what if your point is in the second quadrant, like right here? Well, you do the same, right? You draw a line from here to the point, from the origin out to the point. Now you're going to draw a line that connects, or that intersects perpendicularly with the x-axis. So just draw a line straight down, and then we create a triangle here with the same 3 components: the x-axis, the y, well, the x length, the y length, and then the radius r, and so on. Quadrant 3, you're going to draw the point, then you're going to connect it from the origin, and then draw a line upwards to the x-axis. And then you have your triangle. And then same thing here in the 4th quadrant. So like I said here, draw a line from the point P to the x-axis. So if your point is above, which is the first two cases here, then you're going to draw a line downwards, okay? And if it's the case that you are in the third or fourth quadrant, you're going to draw your line upwards to intersect the x-axis. So what not to do is that if you open up your angle here, like I see on the very bottom, whoops, you don't want to draw a line to the y-axis. Hopefully you can see what I'm talking about. You do make a right triangle, but it's not going to be in the same form as the previous examples, and you're not going to be able to get your trig function values correct. Okay, so it's going to be confusing, and you probably will get the wrong answer, even if your ratios follow the definition. Okay, so this is not the way to do it. I'm showing you because I've seen people do it, so I guess I want to show you the wrong way to do it so that you are aware. The pictures above are the correct way to draw the triangle. What do I mean by drawing the triangle? So here are some directions. Given a point P on the terminal side of an angle, find the exact value of the 6 trig functions, given the point -12, 5. So what do we do? First, we want to draw the point on the x and y axis. Okay, something like this. Now, as we know how to do this, the first point is -12, which means 12 units to the left and then 5 units upwards. So I'm going to say something like that, right? That is where point P is. Okay, so then I'm going to draw a line that goes through it or connects the origin all the way up to that point. Okay, then I'm going to draw a line from the x-axis all the way up to point P, something like that. Okay, so now I'm going to find the different trig functions evaluated at the angle theta, right? So again, let's label everything. So it was to the left 12 units and then upwards 5 units. I don't know the value of r or the hypotenuse, so what do I need to do? Well, we're going to do Pythagorean theorem. So a squared plus b squared is equals to c squared. I have a and b, so I have -12 squared plus +5 squared, and that should give me c squared. So 144 plus 25 is equals to c squared. So 169 equals to c squared, and if we take the square root of that, we get 13. So this right here is going to have a length of 13 units. Okay, now we're good to go and use the definitions from before. So I can say sine of theta, and I'll write down the SOHCAHTOA thing here so that we can remember the acronym. So sine is opposite over adjacent. So what is the opposite of the angle here? Opposite is 5. Opposite over hypotenuse. Opposite is 5, hypotenuse is 13. So 5 over 13. Cosine is going to be adjacent over hypotenuse, and then tangent is going to be opposite over adjacent. So 5 over 12, and I'll just put the negative right in front. Then, of course, we have the other three, which are the reciprocals of the three most popular functions. So cosecant is the reciprocal of sine, which means I just have to flip the values of sine. Secant is going to be negative 13 over 12. And then cotangent is the reciprocal of tangent, and it's going to be negative 12 over 5. So that's how we find the 6 different trig functions of the angle theta, right? We haven't really discussed specifics on the angle theta itself, but this is how we find it, right? We were given the point P. From there, we drew it on the x and y coordinate axis. Then we drew the terminal side. In some aspect, we drew the triangle that we're working with. So this is going to be a very important skill to be able to know how to do, right? You want to come up with a triangle relatively quickly, so that you don't struggle trying to figure out the rest of the problem, right? It's an important piece of like visualizing the problem and then solving it correctly. From there, we use the definitions for sine, cosine, and tangent to figure out their values. And then the same thing with cosecant, secant, and cotangent. Next, we want to talk about the different signs that the trig functions have. If you remember from the very beginning, we said something like, I'm going to draw here on the side, we said sine of some angle theta, and we said it was equals to y. And remember, those points or those values can be positive or negative depending on where they are in the coordinate system, right? So what happens when you have a point that is in the first quadrant, right? Wherever you have a point here or here. Well, in quadrant 1, all functions are positive, meaning sine, cosine, and tangent, along with its reciprocals, are all going to be positive. Perfect. Nothing to worry about there. But what if your point happens to be in the second quadrant? In the second quadrant, sine and cosecant are positive. Everything else is going to be negative, like we saw in the previous example. Okay? What happens if your point is in the third quadrant? The only thing that's going to be positive here is going to be tangent and cotangent. Everything else is going to be negative. And then what happens if your point is on the fourth quadrant? If it falls on the fourth quadrant, cosine and secant are the only points or the only functions that are going to be positive. Everything else is going to be negative. One easy way to remember this is to say a smart trig class, and then the first letter of every word is going to be what function is positive in that quadrant. So in this case, all of them. In this case, only sine. In this case, only tangent. And then the last quadrant, only cosine. Then, what can we expect as a problem. What type of problems can we see for this material? Well, you want to perhaps determine the quadrant where theta is, given the following information. If you know that sine is negative and cosine is positive, well, where could it be? So one easy way to do it is make yourself a little x and y quadrant, and maybe wherever the overlap is. So where is sine negative? Sine is negative down here in the third and fourth quadrant. And then you want to see, well, where is cosine positive? Cosine is positive here. Therefore, we have some overlapping here in the fourth quadrant. Therefore, theta is in fourth quadrant. Okay? And that's as easy as that. You just want to figure out where the angle or theta is, right? Given that information. And if you do the following, it's saying tangent is negative, but also sine is negative. So if you do the same thing, you'll realize that we'll be in the same quadrant. So something like this. Where is tangent negative? So tangent is kind of tricky, and tangent is negative in second and fourth quadrant. Where is sine negative? Sine is negative down here. Where do we have overlap? We have some overlapping in the fourth quadrant. Okay? Now we're going to talk about reference angles. So what is a reference angle? If you have noticed, the way we're drawing the triangles, something iffy is happening with the angle that we're actually finding, because it's not the real angle theta. We're finding the angle of something else, of some different triangle, whenever the point happens to be, for example, in the second quadrant, the third quadrant, or the fourth quadrant. So here's the definition of what a reference angle is, and it's the reference angle is a positive acute angle that we denote theta prime, or theta with a tilde, which is formed by the terminal side of theta in the x-axis. So the best way to look at it is this way. So theta is what we're up until now accustomed to see as the angle between the initial side and the terminal side, right? But whenever we make a triangle, if our point was up there and we make a little triangle here, then we talk about theta as being the angle in here. But that's not really correct. Here's theta, however, we're looking for the angle that's in here. And so we just say, well, that's sine, cosine, and theta of this angle in here. So in red is what is known as the reference angle, okay? For these three pictures, which happen to be in the second, third, and fourth quadrant, they all have a reference angle, okay? The green is the real theta, if you want to look at it that way, and in the red is the reference angle. So whenever we solve like sine of theta, sine of something, here we would say, sine of theta is going to be opposite over hypotenuse, right? So, well, what is the opposite here is this distance up here with this value of r, or the hypotenuse, right? But it's not really this angle out here that we're evaluating, it's more this angle in here. And that applies to all three cases. Okay, so here are some examples. We are trying to figure out what would be the value of theta prime or the reference angle. So remember, this means the reference angle. So for the first example, I'll label it as an A, B, and C type examples so we can understand which one is what. For the example A, I have theta being equal to 135. So what is the reference angle theta prime? Well, we know that 180 is the straight angle minus 135 has to give me theta prime in this case, right? So 180 minus 135 comes out to be 45 degrees. So theta prime is going to be 45 degrees. And that's kind of all there is to this exercises. We're trying to figure out how much is the angle theta prime, or the reference angle. Now, the first example was in degrees, but it can also be in radians. So let's look at example B, and let's figure out what is the measurement here. Well, the reference angle is here in the red. How do we figure that out? Well, 4 pi over 3 is larger than half a rotation, right? So 4 pi over 3 minus pi is going to give me theta prime. Okay, so 4 pi over 3 minus 3 pi over 3 to get the common denominator is going to give me what? Just a regular pi over 3. Well, I mean 1 pi over 3 is what I meant. So theta prime, or the reference angle, is going to be pi over 3. Right? The measurement from the x-axis to here would be pi over 3. That's all that we're saying. In example C, I have this as being my reference angle, this small angle here. So if I want to keep it a positive angle, then I'm going to try to figure out, okay, it's almost a full rotation, right, which is 2 pi. So we can say that this is 2 pi minus 7 pi over 4. And to get the same common denominator, we have 8 pi over 4 minus 7 pi over 4. And remember, this is equals to theta prime. And then we have pi over 4 as the reference angle. So that's how you are going to find exactly what the reference angle is. Okay. Here is how to find a reference angle for something that is larger than 360 degrees, or something smaller than negative 360 degrees, negative 2 pi or 2 pi equivalently, right? So what you want to do, and you know, based on the title here, you may wonder, like, what does that look like? Well, it looks like something in the picture. It's a terminal side that went around many times, and it has a very large angle. So you're trying to figure out what is the reference angle of that. Okay, so what you want to do first is find a positive angle that is less than 360 degrees, right? You're looking for a coterminal angle. Then you're going to draw the angle in standard position. You don't have to, but it's a good practice then. Number 3, then find the reference angle from your drawing. So let's go ahead and do that example with, well, let's work those steps through this example. So if we have the angle theta being equals to 855, so what I'm going to do first is do theta minus 360 however many times I need to, so that theta is something smaller than 360, right? Something positive, so that is within what we consider one rotation or just a coterminal angle. So 855 minus 360 equals 495, and 495 is still larger than 360, so we're going to go and subtract another 360 away from it. .495 minus 360 is 135. Perfect. So now we can go ahead and just graph our new angle, which is 135 and it should be in the same position as the original one, except now there's only a little bit of a rotation to go from the initial side to theta, right? So this new theta here is a coterminal angle with 855. So this is 135, right? And then here, whatever is left in here is going to be theta prime. And then once again, we would do 180 minus theta to get the reference angle. So 180 minus 135 gives us theta prime, and this comes out to be 45 degrees, which is theta's prime value. Okay, so hopefully that makes sense, how to find a reference angle for an angle that is very large or very, very negative, right? Okay, so procedure for using reference angles. The idea here is that you want to become very familiarized with the first quadrant values, right? So if you look at this, you want to understand the first quadrant of values of the unit circle. So these are different points that have different angle measurements, right? Like from here to here, from here to here, right? And each one of them is going to have a different angle measurement depending on the function. Sine of theta, where theta can be 30, 45, 60, or 90. It can also be 0, right? So those are some of the ones that are very popular. And I don't mean that sine of theta is equals to that. I mean that theta can take on those values. So what's the deal here is that, for example, you have theta being equals to 300 degrees. Okay, so we want to find the associated reference angle. So what is the reference angle here? Well, it's the reference angle, or it is the angle that's in here. And we know already that 360 minus 300 is going to give us 60, and that is equal to the reference angle theta prime. So it is easier for us to find sine of 60, cosine of 60, tangent of 60. So step 2 would be find the function value at theta prime, which is what I'm writing down right here. Then, figure out the value of sine, cosine, and tangent at theta prime. Okay, so here we have sine of 60 is going to be square root of 3 over 2. Cosine of 60 is going to be 1/2. Tangent is going to be, let's make some room for this so that it's easier to read. So tangent at 60 is going to be sine over cosine, which comes out to be square root of 3. So, okay, we get this, right? Sine at 60 is the square root of 3 over 2. Cosine at 60 is 1/2. Tangent at 60 is square root of 3, I'm sorry. Now, how can we use this to figure out the actual value of theta, right? Like sine of theta, cosine of theta, and tangent of theta. So remember, all students take calculus or a smart trig class, however you remember this. But look at where theta is. Theta is in the 4th quadrant. Therefore, cosine is the only one that is going to be positive. So what do? We translate those values here and we just make them according to the sign that they have. So in reality, sine of theta, or sine of 300 degrees, is negative square root of 3 over 2. Cosine of theta, or 300 degrees, is positive 1/2. And tangent of theta is going to be negative square root of 3. So that's the idea for using reference angle to figure out anything around the unit circle or whichever quadrant your value of theta lands on. That's how we're going to figure out those outputs, those values, only using the 1st quadrant values and then applying to them the necessary sign. Some are positive, some are negative, and we're going to do that by looking at wherever the actual theta has fallen on. And that is everything for 4.4.